Welcome back. So here's the thing. In the context today, we are going to look into few of the things in the case of advanced Python and stuff. I think our friend here, Aditya, sir, when he took the sessions earlier, and he went into the idea of classes and object-oriented aspect of the things, especially talking about those. We're going to go a little bit more into the things and look into a little bit of the practical aspects of the things, how these things are pretty much used in the everyday life, if I talk about. So, uh, today, actually, the thing is, many of us are actually aware of how Python actually works and stuff. I'm going to little bit elaborate on the things which are little bit unseen to general eyes when it comes to the context of Python and stuff. Because the thing is, being programmers and stuff, we take few of the things for granted. So let's look at those aspects as well. I'll relate those things to the things which we are currently discussing about. And for the demonstration purpose and everything, I generally stick to the Jupyter notebook to talk about because thanks to the Jupyter notebook, I'm able to visualize. I'll be able to show you few of the things which how internally things work out in Python. So we'll look into those aspects and discuss a little bit into the context there. And hopefully the screen is visible and stuff. So yeah, I mean the whole idea behind to talk about is, I mean, in our today's session, we'll stick into what are modules. Furthermore, take few of those and then combine them to see what are packages, and then look into what is a library in general and stuff. So we'll look into those aspects, and I'll also help you recall few things, few of the crucial things which Aditya sir and others, both of them shared in their few earlier lectures as well. So we'll look into those a little bit into those aspects as well. And furthermore, moving out of this, we'll look into what data science little bit is and how you can interact with different kinds of data to specifically talk about, and especially nowadays being talking about huge arrays, if I talk about, right? So how we talk about in terms of working with NumPy, pandas, and matplotlib and stuff. So look into a little bit into those aspects. So I think in general, we all are, I hope, aware of it. Like, if the first point, I think just, can anybody tell me, like, are you able to see the square? If or
Yeah, yeah.
rectangle? Yeah, yeah, perfect.
Yes,
Thank you so
red
much,
color.
sir. Perfect, sir. So I'll be using these few colors. So I think there's the first thing which we are going to discuss about is what exactly are modules, right? So anyone would like to give it a try? Like, we already know few of the things. So anyone would like to give it a try?
Yes, sir. Basically, we create modules when we have to work with some specific task. So we can create some functions in it. And obviously, it becomes like if you are having a py file for that, so you can
Right.
import it as well anywhere, like as
Perfect.
a function.
Perfectly said, sir. Just to add up on the flavors here, right? Just like how sir has described it perfectly, I mean, it can be a combination of, you can see, right? Functions, there's classes, there's variables, right? If I talk about in the context, and the whole idea behind, I think we all safely now know that what a function truly actually is, which makes things reusable or repetitive use, right? So now what we want to do basically is take a set of things which are repetitive and make them reusable one after the other whenever you need it. So we'll look into the aspect, and we're going to create a few things in the context there. So let's quickly talk about in the context here, right? So then obviously, if I talk about a module is it's a single-handed py file or Python file, if I talk about. However, if you have if you have interdependencies on different files, right? Different kinds of you have different py files, right? If you talk about, right, you can put it under one umbrella called as package. Like, you can think and just to talk about in the context, but you can see that The main thing about a package is it contains a init underscore init. Does anyone remember what are these methods called? Sir used a word in the, I mean, uh, Aditya sir, not to, I mean, not to you, because you took the lecture. Others, what are these methods called? If I talk about, do you remember? Anyone?
Constructor, if I'm not wrong.
Yes, sir. Yes, sir. Perfect. That is indeed, just like how we have mentioned, this is called as the constructor, right? But however, right, if you look into, if everyone remembers, there are these kinks on top and something, I write whatever, and then there is these two. So there is a specific name for this kind of a structure. Just like how Raja sir said perfectly, this is indeed the init is basically the initializer or the constructor. It is correct, but they fall under one big category, and that is called as dunder. If you remember, these are called as dunder methods or D under methods, or you can call it as double underscore methods, right? If I talk about, which have special meaning in Python when we talk about in terms of doing a lot of things. And today we are going to look into few of the interesting aspects. I'll show you I mean, how it works out in the at the back end, and we'll look into few more interesting aspects on the same. So I hope that's particularly clear for everyone, right? So the double underscore methods, these are called as dunder methods. And just like how already Raja sir has elaborated, dot underscore init underscore is the initializer, or if I talk about the constructor of the particular class. So we'll look into what this particular stuff is. I just want to add one more point here. After, the package, it says, right, the package is a dictionary, sorry, is a directory that includes a init file, right, or py file, right, if I talk about. But nowadays, after Python version 3.3, greater than Python version 3.3, if I recall correctly, after this, there is no need to, I mean, explicitly mention this as a while you create what do you say, a package. If I talk about, if you want to go ahead and talk about, so that is not needed explicitly. By default, it is not needed in the context, but prior to that, it was in the context. I mean, you had to create one. So we'll talk about it. I'll also show you the examples here. We'll look into how that file looks like and stuff. I will look into those aspects, and it will be interesting stuff to look into as well. So we just discussed about modules. So take a cluster of modules, fit them in with an init file, you get what you call as a package, and take related package and fit it in the form of a library. That's the whole point. And you can see, right, I have mentioned a nice tip here. So you can see that it like I mentioned a pro tip kind of stuff. It says think of module as a tool. Then in that case, a package will be a toolkit, right? Everyone knows what a toolkit is. You have a kit where you have different kinds of tools to work around with the same kind of a stuff, right? And maybe this as a library, as a workshop, because in a workshop you'll have relevant toolkits to work on. So to give a very simple example, let's say we have a geometry box, right? So in a geometry box, you have different kinds of sets, right? If I talk about, let's say, a pencil, a rubber, whatever, right? So then you also have a protractor, right? Or maybe a compass, right? Or a divider, right? So now what I do, these are individual elements. So if I want to go ahead and draw, if my idea is to draw something, I'll use the function, in this case, the object called pencil, and I'll draw it maybe in the context here. Similarly, if my idea is to draw, I mean, let's say measure angles, I'll take the object called pencil, also an object called protractor, and put it on a line and then measure it. So I'm just making sure that we all understand it even programmatically, how it works out. So in a practical scenario. So if you look into, I can club pencil, rubber, sharpener, maybe in one particular bracket, which are used for drawing things and maybe modify with the things. then I can club, let's say, a divider and and a compass in one, because they are pointed objects which can be used to maybe create circles, maybe, what do you say, measure the points between two stuffs, right? You can use that. So I'm putting that in one. So understand this, that I'm putting it in this scenario, that pencil, rubber, sharpener, they are one under the one category. Let's say create. This I can call it as a, what do you say, package. Similarly, I have a divider and a divider and a compass. I'm putting them in the category of, let's say, measures, right? Or maybe, let's say, pointed measures, because they have some pointed needle to them, and they can be used with the others. Similarly, I have a, what do you say, I think that's a set square. You call it as a set square. You have a protractor D, or whatever you call it, right, guys? So all of these things, I'm putting it in under another class. Let's say the shape class. Maybe they can help you with, maybe the shape package, right? So you can see that I have, so you saw these individual components. These individual components are like modules. I mean, pencil is a module, maybe rubber is a module. Similarly, sharpener is a module. Same way you have these D as a module. Each of them is a module. Now, a group of these can be considered as a package. So I'm saying the create package contains related modules, which are maybe which are used to create. So similarly, you have the pointed measurement package, which contains relative modules. Similarly, these, so and so. Now I combine all of these and I create a library called as geometry box, right? So in that context, the library becomes the geometry box, and these of the small segments becomes each of the components of the same, right? So I hope I was able to clear the logic out in this context. Now, uh, is so far so good for everyone? All we do we all get the context?
Yes, sir.
Perfect. Thank you so much, sir. Right. So let's move forward and discuss about few more important things here. So now that you have a idea about in the context of how it looks in the geometry box, let's look at how things work really look within Python. Okay. So in that context, what I'm going to do is I'll go ahead and search for, let's say, Python. I think the entire screen is visible to everyone, right? I'm able to type
Yeah.
and everything. Okay, perfect. Thank you so much, sir. So I write Python, and let me open the file location here. A few things I'll go ahead and relate to for everyone to understand, to see what exactly happens in the context. We're going to look into the aspects here. So you can see this is the place where my Python is installed. C program files Python 3.12, and I have 3.12, that is the 12th version of Python. I mean, version 3 and subversion as 12. So in this context, now the if you look into this particular folder, right? So you see a lot of different things, right? We have a folder called lib, which contains all the libraries which are part of Python in the context here. And let's have a look at few of the things in the context here. I hope, all of us understand. I think the other day, I think day before yesterday or something, we were discussing about a module called as, or a package called, basically a module called as collections. I hope we all remember, right? So we, from collections, if you remember, guys, we all wrote the code that from collections import something called as a counter, right? Which helps me to iterate over and count certain objects. So that guy, basically, if you look into the context here, is located right here. This is the folder which is said as collections. So this is, if I go inside this, you can see that under this, you have a init file. That's like a underscore init file, which we were actually discussing earlier. We are going to also look into how we can create our own, but as of now, I'm giving a feel of how things are actually organized within Python to look into. So you can see that there is the init file, and suppose, let me just go ahead and explore the things, what is there within this. Maybe I'll talk about that a bit, and then we can move forward. I think, let me go ahead and this, I'm using the Notepad++, and let me go ahead and change this guy to Python. It is already set to Python. Perfect. So you can see that this is the init file. You can see is that there is a class called as counter, you can see, which basically helps you to, and if you look into, let's go down and have a quick look at, you can see, just like how we create our own classes, similarly, you have the same kind of orientation in the context here as well. So you can see that within the context, if I, let's say, search for maybe class called counter, and I say, you can see that it accepts something called as a dictionary. You can see. So there's a class called counter, and from there, it's entirely like the internally, if you talk about, right, the counter class is implemented through the module called as collections, right? If I talk about, you can see that internally the entire, so just like how we create our own classes, you can see there are several defs. You can see def total, def. You can see that there was a method called as most common. We basically import from right there. So if I talk about in the context, so I was just giving an example and few more interesting aspects. If I talk about, you can see collections. There is, if I talk about in the context of, right, I'm not sure whether I hope everyone recalls, there is a module called as random. So that is when I say import random, there is a module called random. When we write import random, it basically pings in to this particular place and sees, searches for a Python file called random.py. And then within this, obviously, if I go ahead and quickly, maybe I'll just quickly open this up for the demonstration purpose and stuff. You can see that it contains a, like you can see within random, you can see that there are interdependencies. Can you see from math, import, so and so? You can see that because there are that's how basically you have interdependencies between within files as well. So that's why you might that sometimes we sometimes while doing some installation, all of a sudden we get this error saying that I'm trying to install, maybe let's say numpy, I mean let's say pandas. It obviously says maybe it finds that numpy is not installed. It'll say numpy because the I mean if you look into pandas library, which I'll show you in a minute, right? If I talk about, you'll see many of those structures follow, like they have an internal import for NumPy, and that is why it gives an error message saying that this does not work because you don't have so and so module installed on your system, and so and so. So I think like just to give a particular aspect, it's here which mentions all of it. So if I talk about, I'll also show that particularly in the context here, in the I mean in a little bit more detail and stuff. So you can see there are many of them. You can name it, all of it. You'll find in this folder called as Python 312 slash lib or library. If I talk about, right. So if we are interested enough, you can just look into it and have an interesting aspect behind what how actually Python runs in the context. And similarly, it's not always needed that it has to go to this particular location and search for so and so. That is why I hope everyone recalls that during the setup, we try to set up something called as environment variables. Do you remember? Is everyone right? So if I talk about, right, and maybe if I talk about, let me just, you can click on search button, go to edit and edit the system environment variables. It pulls up a nice screen here. And within this, if I go into, I think, I guess here we have the environment variables. And you can see we set, I hope everyone recalls that we say something like set the path in the environment variables. What this does is basically makes the command prompt aware that you have a particular application installed on the system, right? If I talk about, and that's why sometimes what happens is when you try to run Python, even if you have Python installed on the system, but if it is not in the path variable, like in this case, you can see that many of my things, if you look into, right, there is this Python 312, there is Python 312 scripts. They are all put into the context there. You can see there is one more place within my system from where it is also pinging to Python as well, if I talk about in the context. So that's another particular location which I'm going to particularly visit. If I talk about, let me go to that. So I'll say maybe C users. Let's say go to Saomya, and maybe the folder is app data, roaming. And within this, you also have another folder. You can see Python being, there's a folder here. If I talk about, because you might be wondering that you didn't in the earlier folder you did not see numpy pandas. If I were to talk about, you did not see there. So these guys are actually located in this particular place. It depends on where you have, what kind of permission have you given Python to be accessed. If it is locally able to access or system wide access, that depends on it. So I have given local access, and that's why you'll find many things here within app data, the which is basically user. It's a path which is basically specific to a user. So that's the whole point. If you look into, I go inside this, you'll see site packages, and within this site packages, this is the golden, I mean, egg of everything. If you look into, let me show you one interesting aspect. Let me use right click on it, and let me go to properties. You all remember, right, that we have Python installed on my on our system, right? And Python by itself is only 30 or 35-ish MB, basically not so big enough as a context if I talk about, right? But if you look into this, I mean, it's still reading, but I have close to around 4 GB of storage just taking up in the site packages. This is the brain of where the things are working in Python, actually. So, when we work with Anaconda, it's like a nice bike whose internal cannot be seen, but the external is you ride on it, whatever you have purchased the bike for so and so reason, and you basically do that, right? But what if we go inside it and see how it unlocks, right? If I talk about. So in that context, if you look into the size on the disk, if you see, it's close to 4.5 GB if you talk about, right? So this is the place where things are installed on my system. Now, let me just go into randomly here, and let's say I just type N to go to directly something, directly go to NumPy. You can see that there is a folder called NumPy, right? So I hope that's particularly visible to everyone. This is where what happens basically when you, what do you say? Just a second. I think, yeah. When you write import NumPy. So this is exactly what happens. So when I write import NumPy, it goes to this particular place, checks, is there a folder called as NumPy? In this case, is there a library called as NumPy installed on my system? If it is there, it goes and fetches it. Else, it throws an error, as simple as that, if I talk about. So within this, if you look into Python itself is 30 MB. I think I'm not sure whether this particular thing was visible, but it gives a tooltip here saying the size of NumPy. Okay, is it visible? It's very faint, but the size it shows me as 28.6 MB, almost roughly the size of Python to be specific in the context. Similarly, if I look into, I can click P and you can see I find pandas here installed on my system. And you can see just, I mean, pandas is so big that it's almost like twice the size of NumPy, meaning it's like Python plus NumPy, the size you fit in together to pandas. That's the whole point if I talk about in a very simple, straightforward manner. So it has a lot of different things. If I talk about, right, similar, like you have different kinds of stuff. We all remember the Python image library, or otherwise known as PIL, right? So if I helps to interact with images and stuff, right? So a lot of different things are installed right away here. If I talk about, you can see scikit-learn, scipy, cbond, selenium, lot of, and these are all in the terms of folders. These folders are nothing but individual libraries as big as a library, to be specific. And just like how we all remember, right? I just showed you that particular definition here, that this entire thing is a library. Library is basically nothing but collection of related packages. So let me go to the library called as NumPy once. Let's go to NumPy once and check it. You can see this is the folder NumPy. I click enter there, And you can see there are a lot of different folders, right? If I talk about, I can call these individual folders as packages, individual packages. These guys are individual packages within the set of NumPy. And if you remember, we generally use the random function within NumPy, which is basically nothing but we write from NumPy import random. This is exactly what happens in this context here, which you can see. There is a folder called random, right? This random is very different from the random which you saw earlier. That was random.py file. That is separate, like it is directly import random whatever, because when you write that, you basically import random from the directly available data. Directly available file within the packages there. But in this context, you can see that random is part of this guy here, NumPy on top, which you can see, right? Which basically helps me to import random within the NumPy. So we write from NumPy import random, something in those lines. And you can see that it contains all sorts of, and I think you can understand one more important thing if I talk about, right? So if you look into the structure here, right? These are individual modules if I talk about, right? If you look into, right, I can it is not necessarily like in a practical scenario, it is not always like library module and so forth. So you can have multiple number of hierarchies of what do you say, related packages if I talk about, which can be called as modules, right, in this context. But bottom line is you can see that there is a init file here as well. I hope everyone understands this, right? So you can see underscore underscore init right here as well if I talk about, right? So in the context, if I talk about, so you can see many of these different files if I talk about in the same particular folder, right? So so I think more or less it is understandable that how things work in the code structure. Like for example, there is one more interesting thing which we will be seeing in um, uh, the pandas, right? You all remember, right? We say after importing, import pandas as PD, so on and so forth, and then we say pd.data frame, which helps us to create a data frame, right? So actually, that there is nothing called as data frame directly inside pandas. There is nothing called as data frame directly inside the folder called as pandas. Let me tell you that data frame class is located inside this. Let me show you. So within pandas, right, we talk about, there is, you can see that there is a folder called as core, meaning the core heuristics of how pandas works, right? So if you look into, I'll double click inside this, and within this, I'll go into, there is something called as frame. There is a file, or if I talk about, there is a file called as frame.py. You can call it as a module, individual module, right? So frame.py, and if I right click on it, let me go ahead and open this within Notepad to show it to you here. You can see the frame. Can you see this? It shows me the definition of a data frame here. And within this, by the way, we all know that data frame is actually a class. That means it has to be defined in the form of class data frame. Let me show you. And you can see, I just searched it here. You can see the data frame class is right defined in this particular place. So has a very big elaboration in case you are. So the bottom idea is, if you write import pandas as PD, you can also write PD after importing, you can also write pd.core.frame dot data frame, and then you can create a data frame object. That also works fine enough, because just like how the logic works out, you can see that it is located, this particular file is actually located within a frame, within a Python file called frame.py. I hope that is understandable by everyone. And that's the whole point here, right? So in the context here, obviously, we should not go inside this and disturb these, because if there is some changes here, next time it might not work out for us. So that's the whole point here. Let me go ahead and cross this up. So this is the frame dot data frame file. Similarly, you remember, right? We have series in pandas, right? So we write pd dot series, right? So if I talk about, so in the context, this series is located in a file called as series file, series.py file. How do I know that? If I right click and open it in Notepad++, for all of us, you can see that if I say, let's say class, instead of finding data frame, let me find I write series. You can see here that the class called series is defined right inside this. Uh, Clear? Is it clear for everyone? A little bit, maybe?
Yes, sir. Yeah,
Perfect,
clear, clear.
perfect, perfect. Thank you so much, sir. So I think that's the overall hierarchy which I wanted to just discuss about, like what is basically these kind of small hierarchies we talk about in the context, right? So that's the whole idea. I hope this thing is a little bit understandable, and there are many of those. You'll always find those, each of those right inside the Python folder where you have installed the in the system. So let's come back and look into the context a little more here. So I think we all now understand a few more important concepts if I talk about, right? So the whole idea here is, right, if I talk about, right, how to import modules, if I talk about, right, we have just seen, right, we have just talked about it. Like, for example, I can directly write import math or whatever the name of the module is. I can directly do that way. Then, if I am not satisfied, I want to save some memory. I do not have a lot of memory on my system. I can also utilize the from syntax. I can say, instead of directly importing everything, which will obviously use considerable amount of memory. Imagine if you are talking about a very big library, let's say maybe if we are talking about let's say deep learning libraries, let's say maybe in the context, even if we are talking about transformers and stuff, these are I mean very big libraries if I talk about, right, in the context. So in we do not what our idea is to minimize the memory footprint. So we would like to use maybe something like from so and so import its child or so and so. So I hope that's particularly understandable. The third thing is obviously we use aliasing so that we avoid big names, right? So maybe you have a very big name of a module, you want to cut it short, you can use the obviously as is of what do you say, um, a keyword. Yeah, by the way, I just forgot. Now that I said about the word called keyword, how many keywords are there in Python? Anybody? How many keywords are there
Yeah,
in Python?
I guess it's 27, right?
Sir, it's 35. Yeah,
Ah,
close,
yeah,
close to around.
35.
Yeah, older
Uh,
versions had it.
Confused here.
Older, yeah,
Mhm.
sir. Yeah. So in the
I think not audible.
Soumya sir, you were stuck. Maybe network issue.
hello, sir, am I audible to everyone?
Yes, sir.
Can
Yes,
you
sir.
hear me? Yeah, sir. Sorry, sir, I got off. Let me, my uh, network bandwidth is low. If it's okay for some time, I'll stop my video so that I can save enough for the stuff. I don't know when the light is going to come back. I'll be back. I'll just turn off my camera for some time. Yeah. Am I audible to everyone? It's all good?
Yes, sir. Yes,
Yes,
yes.
Okay.
yes, sir.
Thank you.
Yes,
Thank you so
yes.
much, sir. Thank you so much, sir. So, I think even the screen is still visible, right? All of us. Just
Yeah, good.
quick confirmation. Perfect. Thank you so much, sir. So yeah, just like yeah, I just recall. I'll go ahead and quickly show it to you. It'll be pretty interesting. So there is, there is a what do you say? I mean, there is a module called as keywords. If I talk about in the context, so that I think I'll be able to find it. You can see there is a module. In fact, if I talk about in the context, you can see there is a keyword.py file. So that means I think you all now would be guessing. So I can write something like import space keyword to import the keyword actually. So let me show you this particular guy here, which can help us. So you can see this particular file actually contains all of the things which we just talked about. These are the list of keywords in the context, right? You can see that it is a list, right? If I talk about, and you can see all those special names. If I talk about, which cannot be used in the context of a stuff. So if I talk about in the context, so the idea here is to introduce you to the fact that everything is achievable. So I like when I try to demonstrate the things, I'll probably use import keywords and show it to you how directly how we can also see the list of keywords which are part of it, right? So I hope it's particularly understandable to everyone. I think is the screen visible, guys?
Yes, sir. You.
Okay,
Yes, yes,
perfect,
sir.
perfect. Thank you so much, sir. So I'll show it to you. Yeah, light is back. So light should- yeah, yeah. Okay, perfect. Now, let's move forward to discuss about few more things. So, yeah, so like as we were just discussing about, right? The how you can import the modules and everything and stuff. So now, here's the thing. The if I talk about in the context, right? Like let's say I want to create my custom modules in Python, right? It is always good to have like as I talked about, right? So in the context, have a tree-like structure for your own project wherever you try to go ahead and create a project, right? It is always good to have things separated out. Like for in this case, you can see that I have a directory structure like my project, within which I have something called as my package. Within that, you can see there are three py files if I talk about, right? And in fact, one of them is init file, which where this guy is responsible for maybe mediating between module 1 and module 2 as well. I'm going to like we are going to talk in terms of practicals as well, just in a few seconds now, and in the context there. So I think more or less it is understandable, right? A directory like structure is well oriented in terms of whenever you create a project, right? You have let's say module 1 which defines few things, or a function, or maybe a class, within which I hope methods within the class, if I talk about, or individual functions, if I talk about, right? In the context, we can create all of those in the context there, right? Now, let's move forward and discuss about few of this aspect, right? Organizing your Python project structure. If I talk about in the context there, right? It is always good to organize it in the form of this particular tree, which you see here, right? So if you have data, put, have a nice folder which says data, and within that, put all your data into it. If you are talking about a notebook from which you have dependencies and stuff, you can put that and stuff, wherein you are accessing maybe all of these sources. SRC stands for sources here. So within the context here, so it's always good to have separate Python files for each of this stuff. Like let's say I'm creating a model, then create a separate Python file called model.py. If you are loading a data, create a separate file called data loader.py and stuff. And then it's always, it's not mandatory, but it is a good practice to put tests as well. These tests, what basically they do is, basically if you run those, right, it checks whether the things, or whether the files which you have downloaded and stuff, or you have implemented, correctly implements the particular function, yeah, or not. So it's always good to have tests, although it's not mandatory. Then there is the requirements.txt file, which you can see here. Any idea what is this file? Anybody would like to speak of?
Yes, sir.
All the
Whatever
All
the
the
libraries which you
library
packages
import.
changes
included for
required.
our project.
Right, sir. Perfectly said. Just like Raja sir said. Yeah, yeah, sir. Aditya sir, you were saying something.
Yeah, it was the same.
Same thing. Perfect. So yeah, exactly. Just like how both of us have explained it very nicely. In fact, all the dependencies go into that guy. I mean the requirements.txt file in the context there. So basically, it's a good practice to always put off these things while creating your project. That's the whole point. And obviously, there's the main file, which contains the main code and stuff, if I talk about in the context. Now, let's look into a quick demonstration purpose, and simultaneously, we'll look into how the things work out in the context, right? So, the idea is, in this context, what we are going to do is create our own class, and also we are going to look into how you can put it in the form of a package, then create a module out of it. I mean, sorry, you have a module, then a package, and then so and so. If I talk about in the context of a library, if I talk about in the context. Yeah. So I hope that's particularly understandable by everyone. So let's, without further delay, let's quickly start off maybe in the context here. So, as I said, if I talk about when we were just discussing about, right, it's always good to have your own folder, right? So suppose this is my original folder wherein we are talking about. I have my PPT slide and the others which I have, right? Suppose I want to, or maybe I'll not disturb this particular folder. Maybe I'll create a folder here. This folder, imagine that it is the largest of the entire thing. That is, let's say I'm creating a library. In this context, I'm creating a library called as fraction. Okay, is it understandable to everyone, right? Got it. So in this context, let me go ahead and quickly create this. Let's say, or maybe I'll say fraction library. If I say, I hope this thing is visible. You see that I created a folder called fraction library in my desktop, right? Just to avoid any kind of dependencies and stuff. If I talk about, so I go within this, right? If I talk about, right. Now, in the context here, I'm talking about, let's say, the files which I want to go ahead and look into, right? If I talk about, let's say I am having a folder within this. This is, or maybe I'll probably call this as a, what do you say? Not the fraction library. I'll probably call this as folder, right? Or a project, right? If I say fractions project, I'm creating a project, overall project, right? If I talk about. Now, in this context, I go inside and create a folder here in this case, let's say a fraction library inside this, right? Now, within this, as I said, always try to maintain a uh, tree-like hierarchy, right? So in this context, right, let's quickly look into the context here. For the purpose, for the easy purpose of coding and stuff, I'll probably use my Jupyter notebook, and I'm going to go ahead and copy. And once we make it, we are going to discuss few important concepts right there. And then we are going to put that guy inside, right? If I talk about in the context here, right? Anyways, I should basically have fine. I I've opened my Jupyter notebook. Let me quickly create a what do you say? Python. I mean, IPYNB file here. Let's quickly do that. So, guys, the idea here is I want to create a fraction class, right? So I hope everyone, like, I would like everyone to help me out with here. So suppose, in this context, before I do that, before I create it, I'm going to also, let's say, uh, obviously, a fraction, I think, is in the notation of this, right? I hope everyone understands and the context here. If I talk about, the fraction class is in the context of this, right? If I talk about, right, I mean, containing a numerator versus a denominator, if I talk about, right? But in this context, I'm little bit adding a little one more a bit of not exactly a complexity, but let's say I am importing numpy as, let's say, np in this context here, right? So if I talk about, right, I just want to show you because afterwards I'm going to create something called as a requirements.txt file. So I wanted to show you how the dependencies work out, right? So that's why we are using, instead of, I could have used, let's say, a equals to 12, and I can have, obviously, I can do that, right? I can directly use a number or an integer to create so and so thing, right? If I talk about. But however, in this context, I am using NumPy to show few things which are in required to be afterwards in the context here. I hope everyone understands that I can also do the same thing, like let's say np dot array of 12. It's this one and the same thing in this context because it's just a numeric value which I wanted, right? I can do it. So I could have done it like this, but I'm trying to do it in this manner so that I can show you some more interesting stuff here. Okay. So let's move forward and discuss about that. So I'm importing NumPy in this context. Now, in order to create the fraction class, obviously I write here, let's say, maybe I define something called as class fraction, right? Obviously, this particular class is going to help me create a fraction, right? So helps create a fraction or whatever in the context. I do that maybe in the context here. Now, obviously, the very first thing which I wanted to talk about in the context here, I think I'll just talk about one more important thing before I move forward in the context here. So I think as you all remember that folder which we just saw, right? I forgot to show you one more important thing before I begin. Okay. So let me go to app data. Let me go to roaming. Let me go to Python. Let me go to 312 site packages. There is a folder called JDI. Within this JDI folder, there's the folder called third party. There's type shed, standard library, two. Guys, I think many of us see this particular file here. Is it visible to everyone? Are we all able to see it? Yes.
Yes.
There.
Yes.
Yes,
Yes,
sir.
yes, yes.
Perfect, sir.
Yes. Yes.
There is a file within this called as underscore underscore built-in underscore underscore dot pyi. Pyi files are those files which are interface files, right? You might have seen that. Let me say one thing. You know, right? That interesting aspect of Python is, right? You see that I haven't loaded something called as class integer, right? In order to, I can directly write int1 equals to 12 and int2 equals to 32, and I can do int1 plus int2, right? I can do that, right? But did you see me writing import integer class? Actually, integer itself is a class, by the way. Let me go ahead and open this built-ins.py file and show it to you. I'll open this in Notepad++ just to show it to you here. And let me go to use the language as, let's say, Python, so that we have nice syntax highlighting. So now look at this, everyone. So you can see with this is the holy grail of Python, where things get loaded up even when the moment you open the interpreter. Okay. So if you look into, right, we all know that I think sir also Aditya sir last time he discussed about classes and objects, right? We talked about, actually when I write this, if I talk about, right, everyone, I hope we all understand that if I write type of int1, it says me int, but however, if I say print, if I talk about, we can see that it shows me class integer, right? If I talk about. Similarly, you have other classes. All the fundamental data types have their own classes. All of these things, you might be wondering, where are these located then, right? When we talk about, I do not say that from so and so import the integer class. I don't have to do that, right? But instead, I can directly create an object of the integer class. Similarly, I can create an object of the string class without having to worry about, let's first import it, right? Using the import statement, right? If I talk about, these are all coming from this guy here. That's the built-ins.pyi file. If I talk about, let me show you here. Let's say I say class int. Can you see this here, everyone? That it shows me here that there is a class called integer, and within this you can see that there are numerous defs within this, right? So every class, just like how we all know the hierarchy, right? A class can have several defs, right? But these are all methods we call, right? I hope everyone knows the difference between, small difference between a method and a function. A function exists independently, whereas a method is defined within a class. And that is what is meant by this, right? So we see class integer within which we have a lot of defs here, right? Similarly, you can see here class float. Within that, you have all the methods which are applicable to the float class, right? There is class called complex. You have so and so forth, right? But did you observe one thing, an interesting aspect, that there are a lot of these functions, right? There are a lot of these kind of methods, or they are methods, obviously, right? If I talk about a lot of these kind of methods within, defined within the classes, you can see they are all starting with underscore underscores and ending with the same. Now similarly, you might recognize, it might be a little bit um, overwhelming, but this might be more recognizable. You can see under class string, you have something called as def called capitalize, which we use, like let's say a equals to Saomya, and then that a dot, when we use that dot, you get a list of suggestions of what all methods are within part of that particular stuff, right? You can see a lot of different stuff, right? But along with this, you can also find, if I talk about, there are underscore underscore methods as well, if I talk about in the context, right? So they are all dunder methods, which are also part of it, right? If I talk about. So these interface files get loaded up the moment we open, what do you say? The Jupyter notebook, if I talk about, right? And I hope everyone knows, we all know that even what I say, right? If I say in the context, even, what do you say? The classes themselves are objects. We all know about this statement, right? So that even all, even if I talk about, right, even the classes themselves are objects, right? You know, there is a justification to this. Why am I saying so and so, right? If I talk about, right? So there is a function called dir, which gives you the scope of the things currently part of the stuff. If I talk about, right, in the context here, if I say the dir of built-ins, if sorry, I'll talk about this, you can see that it loads a list of things. You can see that Python already knows about, right? You might have seen that if I just like each of them is actually an object, right? I can't do something like a equals to 12 and then a plus Saumya. Obviously, we all know that it is going to throw me an error, which is a type error. But how does it know that type error is actually there, right? It's because this guy here, the built-ins file, right, is loaded during the time of when you run the what do you say, interpreter. You see all of these things. Can you see? You have a list of errors which are getting executed, right? They are all, these are all classes here, but they are in the context here. If I talk about, they are within this built-ins.pyi file, which gets executed right when you open the interpreter, right? If I talk about in the context. And similarly, if you look into within this dir, you'll also find, look at this, you see int here as well, right? You have the id function, you have input, right? You don't exclusively call them, they all are already part of it, right? If I, you have list, right, which helps you to create the list, map, and all of those things. If you talk about, right, each of them is an individual class which gets loaded up because you have created an object of it the moment you open this up in the context there, right? So in the context here, if I look into, right, so if I look into this, right, so let me say 0, right? You can see it shows me, I hope everyone knows, understands that the type of this guy here is a list, right? This is a list, right? So since it is a list, I can extract the 0th element of the list. It shows me arithmetic error, right? So if I say, if I talk about, right, the ID function, you remember, right? The ID function tells you where the object is located, right? If I talk about, I told you that even the classes themselves are created during the time of execution. And we discussed about the fact that even the classes themselves are objects. And this proves that fact. Each of them, if I talk about in the context here, is you can see that there is an associated ID the moment you run it. Okay. So in the context here, obviously I can write a simple for loop and iterate through to see which at what location are the different things located at the particular place. I hope that's particularly clear for everyone. Is it understandable? Easy, easy to everyone. Did we all get it?
Yes.
Perfect, perfect. Thank you so much, sir. Yeah. So I think that was, I mean, this is what I wanted to maybe talk about. I think acha, by the way, I mean, I think if I talk about, right, even built-in itself is a pi file, right? Everything has to be loaded first as an object so that, just like how we say, right? You want to, let's say, um, contain water in some glass, right? So you have to have a glass object first. You take the glass object, then you pour water into it. So there has to be object created so that you can go ahead and interact with the same in the context here. Same way happens in all of these use cases, what we have discussed just now here, right? So let's move forward and discuss about few more interesting things, right? If I talk about, right? So another interesting aspect is, let me show you. Let's say I have defined a set, let's say 1, 4, 3, and let's say set 2, I have maybe, let's say 4 and maybe 12, right? I say, can anybody tell me what is going to be the answer in this case? Quickly, I just wanted to check once. Anybody?
1, 3.
Yeah, perfect, perfect. Exactly. We all know that if I say subtract set 1 minus set 2, I get something called as 1, 3. If I talk about in the context, right? It's exactly correct. You see that I mean, 4 is, what do you say, omitted out in this context. So what do you think will be the answer for this?
1, 1, 3, 4, 12.
1, 3, 4, 12. Uh, Perfect. Any other guesses?
I don't
Thank
know
you,
it is
Radha,
right
sir.
or wrong.
Yeah, yes, sir. Perfect. Thank you so
Of the
much, sir.
operator
Sorry, sir.
plus
Uh, uh,
operator can be applicable on sets.
yes, sir. Perfect. Perfectly said. Actually, you're right, sir. The plus operator is not applicable within sets. And that is why, if I run this, you get something called as a type error, right? It says unsupported operand types for plus, which is, it says set and set. I cannot add two sets and do this, right? But let
It's
me
not like
perfectly,
union.
yeah, exactly, sir. It does not do the union. So basically, the idea is the guy who created the set class, he did not define what should happen if you have a plus operator. Basically, the idea was that, right? If I talk about, but in the context here, why did set 1, let me say set 1 minus set 2 work is because minus is defined. Internally, the reason why this minus sign works is because internally what it does is this. Internally, it does something like this. When we do set 1, we have a set 1, we have set 2. Internally, what it does is basically it is calling up the method called sub underscore underscore subtraction method, and I'm subtracting it with set 2. That's the whole point. Similarly, I think now most of us might have guessed that, let's say I have int 1 which says, let's say 32, and int 2 which says 12, and I say int 1 plus int 2. This works. Also, I think everyone understands that int 1 minus int 2 also works. Why? Because integer has a defined plus plus a negative, which is defined in the class, and that is why it works. Internally, I think most of you might have guessed that int1 internally it is happening in this manner. That is add of int2. This is exactly what is happening in the context here. Is it understandable? And just to prove this point to everyone here, let me go back to class int and see what all things are defined within the int class. So you see there is def new, and so on and so forth. You can see there is something called as def of underscore underscore add underscore underscore, which is not by default seen in when you press tab to look into, but internally this is what is getting executed. Similarly, you have underscore underscore sub, which gets the subtraction done. For multiplication and floor division, all of those things. You have a lot of different things which you can directly do when you talk about in terms of the comparison. And now let's see class called set. We saw that the set class had minus sign, right? I'm able to do it. So in that context, if I talk about, right, you see that there is a def called sub defined within the set class, right? However, if you look into in this context, you will not find any method which says def of add of or addition if you want to do the addition within the set. Had it been defined within the class, it would all set addition would also have been possible. Um, is it understandable by everyone?
Yes, sir.
All good? Perfect, sir.
Yeah,
Yeah. So this is
Yes.
what, yeah, perfect, sir. So this is what is exactly happening in the context here. And internally, these are the workaround. And look at this, the type error which you see here, it says unsupported operand types. I'll keep this for the change while before I talk about in the context. Now, let's move forward. I think, guys, I'm sorry, I took a lot of time. Maybe we'll take 5 minutes break if you want. If you want.
yes, sir.
5,
15
10.
minutes.
Yeah, that will be.
Uh,
We'll
yeah.
come back
Yes.
in
Okay, sir.
3:30.
15 minutes. Okay, sir. We'll take 3:30.
Okay,
We'll be
great.
back by 3:30, sir.
Yes, yes.
Thank you,
Yeah.
sir.
Thank you, sir, for
Thank you, sir.
understanding our feelings.
Thank you, sir. No, worries, sir. Mm, are we all yes, I said right, sir. So yeah, breaks are never enough, but still, sir, what to do?
Yes, sir.
Yeah.
You
Uh,
can, you can continue.
okay, sir. Sure, sir. So welcome back, everyone. So after the power nap, so let's move forward with the things. So, guys, I think earlier we just discussed about these few functionalities, right? Where I was elaborating about how things work out, right? I mean, especially you can see that it gives me a type error. Why? For a very simple reason that the operation called plus or addition is not defined for sets, and that is why it does not work out. So, and we just saw that internally also there is none. If I talk about, you can see, right? These terms make sense to everyone, right? So we have set difference, set copy, set clear, set add. I mean, many of them things are there, right? Yeah, you can see there is something called as add, set dot add. This will add elements to a set. This is not the same as 1 plus 2. So you can't use the operator called plus to go ahead and do the addition. But however, I can create a set and then add some more elements to it. So as a matter of fact, it this add is very much different from the plus sign which we have here. So I hope that's understandable by everyone that how things work out within the context. And so there is nothing beyond this. Like in case we want to understand what are the different methods which are available and so on and so forth, all of these things are listed right inside the it is only possible to do those things which are defined within the class. Beyond the definition of whatever has been defined, it is not possible to go ahead and do it unless we define. So that's what we are going to exactly look into currently now. So let's move forward and come back to our fraction where we were discussing about. So now that we have a elaborate understanding of different sources, how we saw that underscore dunder methods work and all of those XYZ things, right? Let's now try create something called as a fraction class, because I think Python lacks that easy functionality, right? It has all the fundamental data types, but however, working with fractions is not possible directly, at least not directly with Python, unless and until we go ahead and do something of our own. So that's what we are going to do here. So now, obviously, just like how you saw this, right? I have a class. I created a class called fraction. And and by the way, I think yeah, there is one more important point which I wanted to cover. There is a rule that the name the I mean during the time of discussing about variable names and everything, we discussed one particular naming convention saying that the name of a variable should not, or a name of a class which we create should basically I mean generally when we talked about in terms of naming a class, right? We said that the name of the class should have a capital letter in the context there, right? It is taken for a convention because most of the classes within it are defined within small case letters. And that is the reason why we say that whenever you create, it's not that it is going to throw an error if we try to create a class with a small case letter. It's just to avoid the confusion that internally how the classes are defined, we do not disturb them in the context here. And that is the sole reason why we use capital letters when defining the so and so, I mean, the class name. Because most of the pre-trained, you can see, right? There is a class called frozen set and so on and so forth and stuff. So, um, by the way, do we know what is a frozen set? Anyone? We discussed about set here, right? We talked about set one and set two. What do you think frozen set is? Maybe anyone would like to try? Maybe.
Immutable something?
Maybe immutable.
Yeah,
Yeah.
exactly, sir.
We
You're right.
can
Just yeah,
not change the sets.
yeah, exactly, sir. So you have list and you have what you say tuple, right? we know that both of these guys are equivalent in terms of their power structure. But however, a tuple is immutable if I talk about. Similarly, the tuple equivalent of a set is frozen set. If I talk about, there is a class called frozen set. And I think everyone understands. Do you think, as per the logic, given the logic, should you be able to update in a frozen set? Should there be a method called update in frozen set? What do you think?
No.
No, sir. Exactly. You're right. I mean, just like how we logically think, right? Exactly is the same case here as well. So you know that a tuple is immutable, meaning once declared, you can't change the elements within the same, right? Unless we typecast it or change it to a different form and then do it, whatever, X, Y, Z. But on the other context, just like how sir has also mentioned, a frozen set. Similarly, if I talk about, let me say frozen set, and I'll just use dot and I'll use a tab. Can you see this, everyone? I think just to show you, you can see frozen set can be copied. You have a function called copy. You have a function called difference, like set difference, right? Which we just did, right? There is something called as intersection, but we should understand one thing, that all of these, by doing all of this, you are not changing elements of the frozen set. It creates a new object. It creates a new object and then gives the output or stores the output in that. And that's why you have set intersection, is disjoint, you're checking. Basically, you can see that there are no such methods where you can see that it says update or add. You can't see those methods. Similarly, if I say set dot and I use tab, you can see set is mutable, and that is why you have add, clear, copy. I mean, sorry, copy is just copying. Basically, doesn't make, I mean, it's just, it creates a new set altogether. So doesn't have to be that, but clear, add, all of these modify the current set, right? That's why I'm saying. Then you have discard, all of those things. You can see set dot remove, set dot pop. All of these methods do some changes, either adding some elements or removing some elements. That means you are changing the original set, so and so. But that is not possible in the case of a frozen set. All good, everyone? Easy to understand, so forth, right?
Yeah. Yes.
Perfect. Thank you so much. So that's what I wanted to just quickly discuss about. So an interesting aspect. So there's a class called frozen set. You can see all of those things are pretty much defined in the context there as well, right? So now let's come back to our fraction class. Let's quickly create one. So in this context, I'm creating a class called fraction. So obviously the very first thing, if I'm creating something called as a fraction class, then the guy who is responsible to create is the underscore underscore init or initializer. So I say init. So how does a fraction look like, guys? What does a fraction contain? Everyone?
Numerator, denominator.
Perfect, sir. Thank you so much. Exactly. So obviously the very first parameter I'm going to take is self to refer to the current object. And then perfectly just like sir mentioned, I'll say numerator and denominator. So obviously that takes care of my first definition under this. So I'll say give a numerator and a denominator and create a fraction class. So I like to do things in a proper manner always. So here's the thing. So I have the def, I have created so and so. Obviously, now I'm going to say self dot numerator. Maybe I'll say numerator. That is this particular value, the numerator value I'm assigning to a variable called self because I'm referring to the object itself. So I'm calling that. And same way, self dot denominator di, sorry, and I say denominator. So I think that this these are the main components how a fraction should have. I mean, what a fraction should have actually in the context here, right? If I talk about in the session here, right? If I talk about, so that's the whole point to talk about, right? Now, next, if I talk about in the context here, I am saying, let's say I have just used INIT, right? Then there is a dunder method, which sir has already told about, that is str. I hope everyone recalls the dunder method. Str is used for what do you say? The moment you try to print it, how does the object should look like is what is defined by this guy underscore underscore str. Okay, so let's quickly do that in the context here. I have myself here, right? In the context, right? So within the str, I'm just going to say return. How does a fraction should look like? It should look like in this manner, right? It should have a numerator separated by a slash, right? And there should be a denominator. So I'm going to say return format string. Let's use a format string. And within that, let me use self dot, I'm sorry, I'll probably use this and so and so. I think you can understand. Within this, I'm going to say self dot numerator, and within this self dot denominator. I hope this particular aspect is pretty clear for everyone, right? Prints I'll highlight this word, prints the fraction, because I'm going to tell you something else as well. I'm just using this in the context here, right? This is a doc string. I hope everyone knows that. Every function can alternatively have a doc string or a line which suggests what that function does. It's always good to give that. So I'm saying return f string of so and so. I created a fraction class. Let's see things up until this point. I run this. Okay. Now, let me go ahead and create an instance or an object of the fraction class. Let's say maybe fraction 1. And obviously, in order to create it, I need the name of the class. So I'll put fraction. That is the name of the class. And let me use shift tab. This shift tab will give me the description of what I've just, what all things are necessary, right? You can see fraction can accept numerator and a denominator. And you can see the doc string gives me a nice description about what it talks about in the context here. So give a numerator and a denominator and create a fraction class and so forth. I just gave that description here, right? So now let me come back here and let me take 12 comma, let's say, or maybe I'll just say 1 comma 4, maybe something in those lines. And now let's say frac of 1. You can see, guys, you can see that it shows me when I run this frac, it shows me the object where it is located, right? Yes. So I think you can understand that it shows me the main class, it is located in the fraction at this particular location at the memory, right? If I talk about, I think guys, you remember this same kind of a structure when you use map and so forth, right? I hope you recall that whenever we use those functions, right, it says map object created at, and then it gives a what do you say, a description of where is it located, at what location is it located. By the way, guys, this is the hexadecimal format of the numbering system. I can convert this into its integer representation and get an ID of it, right? So I think you can understand, I can write ID of int. It is located, the integer class is located at this location, but I can also change it to hexadecimal format because this is much more readable. If I talk about, you can see that it gives me in the hexadecimal numbering system so that it's easy to understand and interpret because it has letters along with numbers. It's very easy to decipher. So same way you have the hexadecimal format here, which you talk about. But there is something interesting going on here. You see that it shows that the fraction class is located at this particular location. It is because under the str, I have written something called as prints the fraction. That means I cannot directly use it. If I want to see what I have done, I need to
Print.
exclusively use the print statement. And perfect. Thank you so much. The moment I do that, you can see that the output shows me 1 by 4, which was my original input, which I had gone ahead and put forward to. But But you might have seen, guys, that if I say a equals to 12 and I just write a, it still shows me 12 here, right? It does not show me integer object located at so and so, right? I can also use print of this to show it. It doesn't matter, right? I can write both of it, right? I can just write a, or I can also say print of a to talk about. But you saw that it was not possible here, right? I can do something like that. Let me show you. As of now, you can see that it shows me this, right? Now I go back to my definition. I think there was a very interesting, what do you say, method which was shared by Sir earlier, underscore underscore REPR, otherwise known as representation. Okay. So this is the actual ACTU representation of the fraction plus how it looks like if called directly. Directly, RD or RECT, even without print. So I think we'll see to that. And I just write the same thing there. I just want to return the same thing. Let's do that. And I run it again. You can see the number here. It says 22 now, and I've already run 29. Let me run it again. You can see the number as 30. So I just ran it now. So now if I go ahead and run or create the object of the fraction class, you can see that it directly gets printed out without the need of exclusive print statement. Is the do we all understand the reason why the underscore underscore REPR is there? Is it understandable by everyone? Did we all get it? Understood? Is it clear for everyone? Anyone there? Everyone slept off?
So
Okay,
basically, without
yeah.
print, if you want to get it right.
Yes, sir. So I mean, you might have seen sometimes this is basically printing on the console. Can you see this? The moment you do this, you are printing on the console. But when you use the print statement, you exclusively say print it on a paper. Basically, it will be visible in the context, right? So that's why you might have seen that when I say frac of 2, and let's say I create another fraction, let's say I create maybe 2 by 4 this time, and I call frac of 2, you might have seen that the moment I run it, you won't see frac 1 getting displayed because exclusively you haven't said to print it on the output, right? That's the whole point. So, but however, if I want, I can exclusively use my print statement and I say print of so and so and stuff. I can go ahead and do that. Something understood, everyone? Is it clear for all of us? Everyone, right? Perfect. All good. Awesome. So now we have INIT, we have seen STR, we saw the representation or REPR. Now, obviously, can anybody tell me what, okay, I created fraction 1, fraction 2. So what is going to happen? What is the output of this?
Error. 3 by
Yeah,
4. Error.
3 by 4. Yes, sir. Actually, I mean, it should have. Yeah, exactly. It should have been 3 by 4. Then can anybody tell me the reason why? Why did you say error? Anybody?
Plus is not defined over there.
Yes, sir. Perfect. Exactly, sir. In my fraction class, I haven't created a definition called addition. Yeah, exactly, sir. Exactly. So let me run this and see. Can you see it says type error, unsupported operand type, so and so. And just to tally it, can you see the same error message which we see here as well? For this, because set within set, I told you underscore underscore add was not defined. And same way, we got that same error here. Obviously, in my class, I haven't defined it yet. What should it do if it sees addition? Then what to do, right? Perfect, sir. Thank you so much. Now let's do that. I mean, let's make it aware of doing that, right? So can anybody tell me how to do fraction addition? So I have 1 by 2 plus maybe I have 3 by 4. How do we do the fraction addition? Anybody's?
LCM of denominators will take
Dot multiply the
Right.
numerator denominator of the second fraction.
Right. Perfect. Perfect. Exactly. I will probably use LCM of the denominator and do the same. But the idea here is pretty simple, just like how sir has mentioned here, right? So we'll probably take 1 multiplied by 4, right? Yeah,
Yes.
exactly. Exactly. Plus
Into
3
2
multiplied by 2. Exactly. Perfect.
by
Perfect. Perfect.
into 4.
By, yeah, 2 into 4, just like how sir has mentioned, exactly like that. And then we simplify it further, just like sir mentioned that we can take the LCM of it and then go forward with the thing. But I'm going to keep it very simplified. We are going to take this expression and write it exactly the way it is and put it forward in this context. So I'm going to take, so I think everyone understands one thing, right? There are two fractions, right? This is fraction f1, this is fraction f2, right? Suppose I'm calling this as self, right? And I'm going to call this as other, okay? I'm using these names, okay, for f1 and f2. Now, based on that, okay, let's create our definitions right below. So I'll say def of, I think everyone understands. I'm going to say fraction addition underscore underscore add. So under this, how many parameters do I need, guys? In order to do the addition, how many parameters do I need?
2 self and
Yeah,
other.
exactly, sir. Perfect. Yes. I will be needing a, I can also write F1 and F2. That's fine, but it's better to use the self convention. Thank you so much, sir. So self and other. Perfect. That's perfect. Now I have def of add. Under that, this what it does is adds the two fractions together. Perfect. Brilliant. Now let's move towards and talk about. So I have to do this operation, right? I hope everyone understands the context. I'm not going to simplify it further. We are just going to stick to basics so that we understand the context. But as a homework, at the end, you can take the further context where you simplify it further, the numerator and the denominator, and get the lowest possible outcome of it, right? So let's quickly look into. So now my idea here is, right? So there obviously the output should have a numerator and a denominator again, right? So let's say I call it as temporary numerator. I say temporary numerator. So what do I write? What will be the calculation here? Can anybody tell me? What should I write? The reference is here on the right hand side. Yeah.
So it
Sir.
should be self numerator
Perfect. Yes, sir. Self dot.
into self dot numerator
Yeah. Perfect, sir.
into
You have 4.
there is
That means
another
the,
4
yeah, right, sir. So this would
other
be, yeah, perfect. Other
the
the,
other dot
yeah, I think I wrote it.
denominator.
Yeah,
It's
right.
other dot denominator
Perfect. Exactly. So this is what I'm going to do and add it
plus
up.
other dot numerator into
Yeah. Perfect, sir. Into self dot denominator.
denominator.
Perfect. Perfect. So we now have temporary numerator. Similarly, I'm going to create temporary denominator. I think all of us understand the context here. MENATOR. Yeah. So I think that would be perfect. So I'll say self. Yeah.
Self dot denominator into other dot
Perfect.
denominator.
Perfect, sir. Other dot denominator. I hope this convention is clear for everyone. I'm just for the sake of nice visual, I'm putting it in brackets. Doesn't matter. You can remove the brackets. That's okay. But for convenience, I'm just putting it in brackets. But AKA, that doesn't mean I'm putting a tuple. It doesn't mean that way. It's just doing the calculation and doing. So I hope it's particularly clear. Perfect, sir. So now, obviously, I've done the addition, but it's still not complete. What should I do next?
To return it or print,
Yeah,
return the.
exactly. Right, sir. I'm going to say return. Let's say I'm in this context. What should I return, by the way? What should I write?
The temporary numerator
Perfect. So f of,
or f of
yeah,
no the yeah
this, right, sir?
temperature numerator, yeah.
Yeah, by, I can put it as temporary denominator. Perfect, sir. Brilliant. That's nice. So just like that, we just created a fraction addition, right? So I think, let me run this off. Perfect. Thank you so much, sir. Let's see if now our addition works, right? So I have frac 1, I have frac 2. I ran it. So by the way,
I think
I
we
run
can
this.
also give
Yeah.
it in the form of underscore underscore str underscore that function.
Uh,
In the
yeah.
return,
Mhm.
when you return
Right,
it,
sir. Mhm.
you can return it in the form of that function underscore underscore str
Yeah,
underscore underscore.
function dot underscore str, and then you can put it off in that manner. I think
In
you're
that
talking
manner.
about. Yeah, yeah, yes, sir. I'm just trying to make it simplified so that
Yeah.
it's understandable by everyone. Perfect. Yes, sir. Exactly. We can do that as well. Perfect. So we have this. So we have the init, str, and so on and so forth. I ran it, and I'm going to recreate the objects. I hope everyone understands. This is 37 number. I have to re-enter that because it says 33 still. Let me rerun it. Now I have again 1 by 4 and 2 by 4. Now fraction 1 plus fraction 2, you can see that it shows me the output here. Like if I talk about a simple, straightforward manner, if I talk about in the context, I have 12 by 16, which is obviously not simplified. However, it does the trick, right? If I talk about, but however, as I said, that's a separate homework task for all of us, that you can simplify it further. So think of ways of simplifying it further, because this can be, again, the common between them is 4, right? So it can be divided by 4. If I talk about, you get 3 by 4 again. So that should have been the actual output. But however, whatever we have done so far, it gives us in this manner. Is it understandable by everyone? Everyone got the context here? Is it clear for everyone? Yes? Perfect, sir. So, yeah, there is one more important thing which I wanted to say. Suppose I say I create another object called fraction 3 using the fraction class. I create, let's say, 1 comma 2, right?
Is it my internet or Saumya has lost the connection?
Soumya lost the connection.
Am I audible to all of us here?
Yes.
Hello?
Now it's audible.
Now, yes, you're audible.
Again, light went off. So power cut again. So sorry for that. So let's say I store it in form of addition. I say frac 1 plus frac 2, and addition, I say so and so. It gives me this, right? If I talk about, right? Now I say print of so and so, right? If I talk about. Now, obviously, I think this is also a fraction, right? If I talk about. So can anybody tell me what will happen? Let's say I say frac 3 and I say fraction class frac 3. I created frac 3 here, sir. Am I audible to everyone?
Yes.
Perfect.
Audible.
Thank you. Yeah. So I just, I mean, put this in the form, like I put it in, you saw, right? I created fraction 1, fraction 2, and then stored the addition in a variable called addition. Now I'm adding, uh, I created another one called as frac 3, right? Saying 1 by 2. What do you think will happen if I say addition plus frac 3? Plus is defined, right? What do you think will happen? Uh, all of us, are we able to hear? Yes. Did we all get the question? Yeah. What do you think will happen? I mean, whatever feels like. I mean, no hard and fast rules and stuff. But what do you think? Did we all get it? I created frac1, frac2. I added it and stored it in addition called as variable addition. Now I am taking this variable called addition, which becomes the self, and frac3. I created another frac3, right? And I added them up. What do you think will happen?
I think it has to add this time. Is it?
So meaning, sir, it will go ahead and add this and this. That's what you feel, right, sir? Yeah.
Yeah.
So let's see, sir. You can see it shows me a type error, right? So basically, you can see the error message. It says can only concatenate string and not fraction to a string. The reason why is because let's see what is the type of, what do you say? What was it? Addition. Let's see what is the type. Can you see? The type of addition is str. I am forcing this guy to be manipulated by frac3. I'm trying to add this up. This is a string, and I'm trying to add it up with a fraction. Obviously, both of them are worlds apart, so they don't go hand in hand. The reason is pretty simple, just like how we were discussing earlier. There is a small change I need to do here, which says, in this case, I'm saying return. I hope everyone understands. I'm saying that for the type of, what you say, the return which you are getting here is nothing but because I'm using f, right? And f is a string. It is basically a f string. This entire thing is a f string, right? So that is why basically the output of this add function is a string. Instead of that, I want it to be fraction. What can I do? What do you think? What can I do?
Return it in the form of fraction. We have
Yeah,
initially made it a
exactly.
fraction.
Perfect, perfect.
So that's what first I was
will.
thinking, is
Yeah,
telling you.
exactly,
Yeah.
sir. Yeah, I know, sir. That's what you were talking about, right? I hope everyone understood the logic behind. I wanted to share in the context here that how errors happen and why errors happen. So these are the few aspects. So I can say fraction, and I'm going to just write, I'm going to return, what do you say, temporary numerator and temporary denominator. Why? Because I already have the fraction class. I'm just calling that again. And if I run this now, I run this now, and let's say I'm storing it. You can see that it shows addition here. I create fraction 3. Then let's see the type of addition. You can see the output of addition now becomes main dot fraction. That means it has become a fraction class. And type of frac3 is also fraction, and that is why if I run these two guys together now, you would get the output as 40 by 32, what it should usually have to be done. All of us understood the concept here? Perfect, sir. Perfect. And just like others, he already mentioned that. And I hope the chain of thought is clear for everyone, right? So how things work out and why, right? So now, guys, I think more or less, more everything remains the same. I'll probably copy this guy here, maybe paste it. I'll add some few more methods just for the sake of saving some time. I think I hope everyone remembers how to do subtraction. I'll probably use underscore underscore sub. At this point where I used plus, all I have to do is for doing subtraction, I'll use negative sign. That's it. So that's how you do fraction subtraction, right? Similarly, this does not add, this subtracts or whatever. And then I have, let's say, multiply. I want to multiply. So in this context, do you know how fraction multiplication is done? Numerator into numerator by, yeah, perfect. Numerator into numerator by denominator into denominator. So I'll probably say this guy, and I'll probably use this, whatever. So I have this and self dot denominator and other dot denominator. I think more or less we are done. I have multiplication of multiplying the or whatever. And by the way, in there is something called as here in Python, you don't have underscore underscore div for division. Unlike that, here you have true or true div, meaning you're doing a true division. Okay, so many of the people a little bit get confused because in the context here, you'll also see true divs almost part of everything. So if I talk about in the context here, let's say class integer, you all remember, right? In two integers can be divided very easily, 2 by 4, you can do that. And I think you can understand there is something called as I can also define floor division. There is div, but in the context here, this is responsible. The true div is responsible for actual division. This is deprecated. The whole point of earlier, it used to exist earlier, but now in the original, that particular original set is what do you say done for. Why? Because you can see these were this standard library. You can see on top, guys, that it shows me 2 after that. So this is version 2 of Python where it was actually built in. Okay, so I think you can understand standard library /2. That means version 2 of Python. So it's more or less obsolete. So new definitions have come up, and that's why you have true div in the context. Is it clear for everyone? Everyone, easy to understand, right? So same way, I have this. So def of true div, I talk about, I have the enumerator, let's say self dot, I think everyone understands that in order to do the division, you take the self and reciprocate the other one, right? So if it is 1 by 2 into 1 by 2, that means you do 1 by 2 into 2 by 1. You reciprocate the second one to get the division done, right? Everyone understands, right? So in that case, all I have to do is maybe I'll just copy this code here because it's pretty much exactly the same. But however, let me have this, yeah. So I'll take temporary numerator. So I have self dot numerator and other, I'll take it as denominator, and self dot denominator ka, I'm going to say multiply it with other ka numerator. Is it understandable by all of us? Got it? Everyone
Yes,
got
sir.
it, right? Yeah,
Yes, yes.
perfect, sir. Thank you so much. Perfect. So this becomes my, this does not add this device. So I have, we have just created, what do you say, a elaborate fraction class and put forward the into the context. Now, obviously, I have defined everything. So I think all of us understand the context here that if I talk about, right, the fraction addition works out, right, I can also use dot, if I say, you can see this, right? This proves the fact that internally, when you use the plus operator, it actually does this, right? I hope everyone understands in the context here. Is it clear for all of us? Yes or no? Understood, right? So that's
Yes,
exactly
yes.
what I want. Perfect, sir. Thank you. So I think, guys, that's understandable. Now that we have created this fraction class, how do I create a module of it? Very simple. I copy this guy from here and I go to maybe I just what do you say? Where was that desktop? I had created a folder, right? What was the name of the folder? I forget things sometimes. Yeah, fractions project and fractions library. Under this, I'm going to say I'll probably create a new file, right? Or let's say, I almost forgot I had this thing opened up. So I'll probably create a new file here, maybe paste it. Let's change the language to Python, maybe. And let me go to file and save it as. This is, I think, guys, we are not living in the Stone Age. What I'm doing here is all working around in the Stone Age. Pardon my mentality, guys, but still, that's the whole point. Uh, so let me quickly go to the project folder so that I just want to explain the process, the thought process of everything. So now I just created this entire thing. So let's quickly maybe use, let's say, frac py. I think everyone understands it is very important to have a, what do you say, extension. So frac.py is the file name. And I'm going to save it up. Let's go back and see if the file is created at the desired location. And you can see here, I just created the folder, or in fact, the frac.py module in the folder here, right? So if I talk about, right? So obviously, since I have created this, right, I can also, what do you say? I can go ahead and import this same thing in the file as well if I talk about. So supposedly I wanted to import this, right? Suppose I want to do that. I can go ahead and maybe do the same. Let me just use kernel and restart the kernel so that it forgets whatever state it is in, right? So let me restart the entire kernel. Now, I think we all understand. I just import, I'll use the import keyword, and here track. You see, right? You remember, right? By the way, did you see one thing? After writing few words, I press tab. You can see that there is a, what do you say, M or module called as fraction here, right? You can see that, right? And it shows me that this is a module, right? So which we just created, right? So I think you can understand in the context. I have imported frac. Obviously, how do I use it? So I say frac dot, within the frac, there is the class which I created, right? The fraction class. I can do that. Maybe I'll probably use 1 comma 2. You can see I created the fraction class. Obviously, that works pretty straightforward enough, just like how you talk about in the context there. Clear, everyone? Understood, all of us? Perfect, perfect. That's great. So we just created our own module and looked into the context there. Obviously, I can go a little bit, a step further, right? You saw that I created one particular what do you say? By the way, did you observe one thing, guys, that the moment I ran this file, right, there is a folder which is created, underscore underscore py cache, which is created. And look at the timestamp here. It is just now. You can see that the file was created, or the folder was created at 4:12 p.m. And according to my system time, you can see it is 4:13 p.m. So this basically ran the moment I ran this. The moment I imported frac. Okay. So, this particular guy actually, uh, we say that Python is slow, right? But the internal structure of Python, how it works out is basically, you can see the type of file which is there inside this PyCache. It says compiled Python file. If I talk about or PYC file, this is a PYC file. This helps in faster execution of Python code. Next time when you try to run this, right? It does not, if you have this PyCache folder created, right? I can delete it. Look at this. I'll just use this. And are you sure you want to permanently delete? Yes, I deleted it. Okay. Now, if I run it again, import frac, the moment I do that, and if you look into, right, let me go ahead and let's say frac dot fraction. The moment I created the init, and if I say 1 comma 2, let me go ahead and refresh it once. Okay. I do not see it again. Track module. Okay. Oh, I'm sorry, guys. Actually, the state of the system is still preserved. I hope you understand that how the actual implementation is, that the RAM still has the information until and unless I kill the session and I restart my kernel, right? It's still, the RAM still has the information that even if I delete fraction, right? Even if I delete this file from here, it will still be able to do the execution. Why? Because it has already been imported again, right? So now I have to, let's say I restart my kernel again. Let me do the restart again. And let me just say import frac, right? And can you see this? It recreates this folder underscore underscore PyCache, and you can see the timestamp. It just got recreated just now, right? So basically, this is what happens at the back end, right? When you try to run any kind of a file in the context here, right? So let's come back here. Maybe we just understood the context here, right? So you saw that we just created a module, right? I think you can understand. Let me come back to my PPT, right? Once, and let me go back on top a little bit. You remember, right? That we described about these few features, right? A module is a single Python file. What we just created now is a single module. All clear about it? Everyone understood, right? What we just created just now is a single module, right? Suppose I want to use this init and maybe that module combiningly, I want to go ahead and create a package, right? In that context, let me go ahead and do that quickly, right? I'll not, use any additional stuff. I will probably use these definitions, right? Because I've already created it. But if you are really interested, you can create a lot of different things. You can create your own world of fractions in the context here. So, but for the convenience here, I'm just, yeah, what do you say? Just putting forward these things again. Let me use this as Python. I just copied and pasted everything. You saw that like we already have the init, right? I don't need these string representation I don't need. I want to create functions. So this file, this Python file, which I'm creating is going to create functions, okay? Rather than talking about methods. So instead of saying add, I'm also implementing the same thing with a function called addition, or maybe I'll say frac addition, right? If I say so, similarly, I'm just repeating it for the easy understanding, but you can always have your own set of different things. Subtraction, SUBSTRAC. Yeah. Am I correct? Subtraction. I think, yeah, subtracts or whatever. Subtracts. SUBTRACT. I'm sorry. Yeah. So frac multiplication, maybe. And I define one more, let's say, frac division. Let's say division, right? And I just, for the sake of understanding, let me create this as a separate file, right? Although I told you, right, you can implement your own functions to do a lot of advanced stuff. But in this case, let's say I'm saying operations, right? So maybe I'll say frac operations or operations, whatever. And I'm saving it in the same folder as fraction library, right? So you can see that now you can see that it contains a fraction file, but same thing also can be done using operations. But the only difference between the two is, right, you see these are individual defs, meaning these are functions. But if I talk about, these are classes. These are methods because they are defined within the faction class. That's it. I'm just doing the same thing for whatever, like just like how you saw, right? Set different. I can use set one dot difference set two to do the set one minus set two, or I can use set one minus set two as well, right? Same thing. I'm just recreating it. You can, obviously that is foolish, but still, at this point of time, I'm just giving a heads up that if I create two different Python files, how do I integrate it together, right? That's the whole point here, right? So you can see I have created this fraction operation, and many a times our idea generally remains like you want to use this untitled file, not here, maybe here in the main folder or main directory, maybe, right? If I talk about, right, if you are storing it in the format in the context, because you want to go ahead and import the necessary libraries, so which are basically part of the other stuff, right? So in the context here, I have these files. Let me go ahead and do that. Maybe I will quickly, oh, I think, let me go ahead and quickly run this up again here, just show it to you here, right? I have these files, right? Let me run this. Okay. All right. I do have my fraction library, which contains my tree, like just like that, which we just discussed about, a fraction file and the operations file, right? If I talk about, and let me go back here, right? So in this context, I hope you can understand. This also gives me a scenario here saying that what if now if I want to go ahead and import it, right? Did it stop here? This. Yeah. So So now in order to maybe import or do the importing here, right? I have to go inside because my frac file or frac.py is located inside this, right? I hope you can understand. It is located in fraction library, right? So in order to go into that, if I talk about, I can say, or I'll say probably from my name of the module. This is acting as a module in this case. I hope everyone understands. Fraction underscore, or in fact, library, right? So I'll say maybe from, let me come back here, fraction library, that is my module. I am importing, right? If I talk about in the context, right? The fraction class, right? If or fraction, what do you say, module, which is located within the fraction library, right? If I talk about, right? Now that I have done that, obviously, frac dot the class which is within that, and obviously I can go ahead and create my own fractions and do all sorts of things in the context. I hope it's particularly clear for all of us and we all understand the context here, right? But however, there is the operations.py file. Supposedly, I wanted to take that into account as well, right? So if I talk about in the context here, right? So if you look into, right, this is the exact, you see that I have created a file called frac, a file called operations, right? Now, the idea here is I want to combine these two together. And that is why I will probably use a file, or let's say, I'm going to say, let's say I'm going to use a, let me go ahead and click on save as here. I hope everyone understands here. Let me go to the fractions project. So under this, I'm going to say, let's change it to my Python and let me go ahead and save it up. Now, let's go to desktop. Let me go to the fractions project, fraction library. Here, I'm going to create a file called underscore init dot dot py file, right? So this is the one which will be responsible for acting as a mediator between all the three, if I talk about in the context, right? So let me just, I told you, right, I can remove all of these things. These are save points or checkpoints or whatever you are going and created, right? I just have these three files in the context here. I created fraction, I created operations, and I created init file, right? And within this init, I'm going to write the code because here, I want to initialize it the moment I call the folder, right? The folder meaning fraction library. I would say a library when I want to directly initialize it. And for that, I will say in this file, I can directly say import. I think I'll go ahead and say, let's say, or I'll probably say from the fraction from frac import, I'll probably import the name of the class is capital fraction, right? That is my, what do you say, file which I'm trying to go ahead and import, right? If I talk about, right? Similarly, I have this operations file, right? If I talk about, right? Because I want to combine both of them together, right? So in the context here, let me go ahead and just save it. For now, let me just do this, okay? And if you look into, right, let me go to kernel and restart the kernel to talk about, right? Let's go ahead and try to do that. Let's say from fraction library, I want to go ahead and import, I think the name of the class, I already have it. You can see, guys, it shows me the error as module not found error. It gives me the error as module not found. It says there is no module called frac in this, right? For a very simple reason is because I am saying in this file, I'm saying from frac, I'm importing fraction. Here, I should first refer to the current directory. And to refer to the current directory, I think everyone knows here, we use a dot to talk about the current directory. The current directory is represented by using the dot. All right. So I'm saying from dot fraction, I'm going to import fraction. Now, let me go ahead and save this up. I save this file, come back here, and you saw earlier that it showed me module not found error. The moment I do this, because I'm referring to the current directory by using the dot, right? So many a times you in the code, whenever you see the dot, that means you are referring to the current directory. Clear about it, everyone, right? All of us understand the context here, right? So I think more or less we all understand the concept here. And the moment I do that, you can see that the pi cache in this context, you can see it is having this init of um, uh, C Python, if I talk about, and the frac.c Python. So I told you the compiled Python file, if I talk about, right? So in the context here, right? But there is still no linkage to the operations file, right? So I would simply go to my operations file because I have defined operations for fractions, right? In that case, I'll go ahead and right click on it. Maybe I'll edit it. And on top, you saw that earlier I started with the definitions, but who should it be applicable to? And that is, it should be applicable to fractions. And that's what I'm trying to do here, right? So from, sorry, import, let's say from frac import fraction, because it has dependency directly on the fraction class. That's the whole point, right? So because I want to use fraction addition on top of after creating the fraction. I hope everyone understands the context here. So I'm going to save this up, and maybe in the context here, right? If I talk about, right? So let's say in the context, I have the init file, and within this, I'll probably say from this current directory, import my operations, OPERA. I think operations.py. This is the name of the file, right? So I'm going to say from the current directory, from dot, that means the current directory, import the file called operations. And now, once I'm done with that, obviously, if I go ahead and do the operations, right? So let's say import, let's say, or maybe I'll go ahead and again, I'll also use operations. I hope everyone remembers that we can also use this syntax, right? So from the name of the library, I'm importing both the files called fraction and operations, if I talk about. And it shows me no module named frac. Let's have a look. Where have we made? Yeah. So you can see here also, I forgot. So let's say dot frac, because I want to refer to the current directory. And you can see now it works perfectly fine in the context here. Now that we are done with the context here, let's say I finally, all I want to do is maybe fraction class, right? If I talk about, right? So, I mean, frac dot fraction. I think you can understand, guys, that I have used frac. So I have to use frac dot fraction. Had I done it as from fraction underscore lib dot frac import fraction, I would have directly used the class called fraction. Everyone clear about that, right? I think it's pretty easy to understand. Got it, everyone, right? So I think I'll go ahead and just quickly do that. Maybe A, and we have the same. If I talk about in the context here, we have, let's say, 3 by 2. And I think this is possible also if I talk about, right? So dot, you can see that I can go ahead and talk about in the context there, right? So I hope it's particularly understandable by everyone if you look into the context, right? So this is actually what I wanted to talk about in terms of a structure which you are talking about, right? So this enables us to have a nice modular way of approaching the problem which we have at hand, right? So that's what I actually wanted to talk about in the context. Now, guys, I think all of us understand that it is very much important to also have the requirements requirements.txt file when you create your projects, right? I hope that's particularly understandable by everyone, because that way you can always have your, what do you say, dependencies. I mean, without any dependency conflicts, right? If I talk about, and you can always download from the requirements.txt, you can download the relevant packages which are part of it, right? So, there is a nice package called as pip reqs. Have you heard about it? Pip reqs. So this actually helps us to generate a requirements.txt file. Many of us might be aware of pip freeze, which helps the system to be frozen and all the dependencies to be extracted. So I can use pip freeze, then greater than symbol, and I can write the contents to a requirement.txt file. But the problem is, let me probably show you here. Let's say I use my command prompt, right? So I say currently in the there is a big problem here if I use pip freeze. And the simple analogy is, if I use this command pip list, right, it shows me all the, what do you say, you can see all the relevant packages which have been installed on the system, right? I hope it's particularly understandable. And if I say pip freeze, and then I can write pip freeze, right, and I can generate something called as requirements.txt file. I can do that, right? So I think you can understand the context. Pip freeze. Okay, I think okay, fine. Ah, you see that this command got executed successfully, right? We have pip freeze requirements.txt. This generates a requirements.txt file at C users Saomya, if I talk about, right? And if I look into, let me go to that C, I will probably go to users, and let me go to Saumya here. And you can see that, you can see the timestamp here. This got generated just now. I think it is understandable. And the problem here is, you can see that it gives me all the packages. But I think you can understand this project was not created with any of these packages, right? If I talk about, right? And that is where pip reqs, another package called pip reqs, comes into play. So pip required, what it does is it goes or scans through the current, what you say, directory, wherever you run that, okay, and it generates a requirements.txt file, right? So let me show you what I mean by that. Let me go to this fraction library, right? I have this, right? I maybe run this here, right? So how to install it? I think we can understand. You can use pip install pip reqs. So this is the name of the module, right? So if you talk about, right? So, and if I show you, I already have it installed on my system. So if you look into, I think pip PIII, where is pip? Yeah, can you see this? This is the module which I'm talking about. I already have it installed on my system. At this point, I opened my current project directory. Now, I'll use pip reqs. That's it. I just have to run the command directly. And basically, it does not scan Jupyter notebooks, but you can always use the help and find out what all additional parameters it can. You can also ask it to scan Jupyter notebooks as well. But generally, it goes through all the Python files inside this folder, and it generates, can you see this? It generates a requirements.txt file. So let me just open it for you, just to show it to you here. You can see the requirements.txt file is completely vacant because there has been no dependencies inside it, right? If I talk about no dependencies on pre-existing packages, right? So that is why I was saying that let me import NumPy, okay, just for the sake of showing in the context here, right? Although we are not going to use NumPy, I'm just wanting to show it to you. So let me go back to my original directory here. Where is it? I think I in the correct folder. Yeah, I go here. I'll just randomly go to maybe fraction file or whatever, and let me go to edit that. Somewhere on top, I just write here as I'm just randomly writing. Maybe there is a as NP. I just gave that in the context here, just for the sake of I mean, just to show you how the pip requires actually works, right? Now I saved the file. Okay, let me rerun the script, or let me rerun this pip reqs at that particular same location. Okay, let me run it again. And warning, yeah, it already exists. You can, it says use dash dash force to override it. So I'll probably use force to override the existing one. So if I talk about, and it goes ahead and warning humpy, you can see that, right? Now let's have a look at how our requirements.txt looks like now. And let me open this up. You can see this. It generates the, I mean, requirements.txt file based on the um, aspect which is needed. But on the other hand, if you try to generate it using, as I said, right, let me use CLS, pip freeze, right? I hope everyone understands. I want to generate req.txt. I think you can understand. This generates the requirement.txt file, but as I think you can understand the context here, it shows a list of all the packages which are system-wide available on my system, right? If I talk about, right? So that's what I wanted to quickly talk about in the context here. And I hope we all understand the context behind as to what is going on at the back, right? Is it clear to this point for everyone?
Yes, yes, sir.
Thank you, sir. Okay,
Yes,
perfect,
Soumya sir.
perfect.
Yeah, sir.
And yeah, thank you so much, sir. So I think as we talked about, right? The best practice of doing a project is always create these files, right? And as I said, like it's always better for resolving any kind of conflicts. It's better to have your own virtual environment, right? You can use the VNV module which is there, so you can create your own module and then I mean own environment, right? A virtual environment, and then you can do your project inside that so that there is no dependency conflict between the same. And in that case, you can still use pip freeze to talk about, because if you download or install it from scratch and then do it, then obviously things will be not there in the context there, right? So I think you can understand the context. Apart from that, more or less all the other points are clear because we saw it in the form of a practical, and everyone understood the context here. I'll quickly zap through a few of these things. I think Sir already had informed, but I think it's pretty much the basic stuff, right? Use the OS module or the operating system module to interact with the OS, right? I hope it's particularly understandable. And within that, you can see the file system utilities you have, right? The standard libraries which are provided in the context here, right? Or shutil, basically nothing but the shell util, which or utilities. This gives you additional functionalities in the context that you can copy or move, doing a lot of aspects which you basically do in the context of a stuff, right? If I mean in the context of normal working with files, if I talk about, right? So you can see making directories or sub stuff in the context here, right? So create a directory, copy files, and so on and so forth, right? So obviously it accepts the regular parameters, right? Obviously, when you talk about copy, you copy from, and then where do you want to copy it to? So basically that. Same way, move, you where you have the original source, where do you want to move? So that is the parameter which you pass through in the context, right? So pathlib is, I mean, a very, I mean, if I talk about came up afterwards, right? Initially it was not part of it. So wherein you like you have advanced functionalities when it comes to manipulating paths and everything, right? If I talk about in the context. So I mean, more or less, if I talk about in the context, right? A very simple project which you can see. We saw a little bit of a complex examples earlier and stuff, but this is pretty straightforward, basic. I think you can understand. I am saying list the, at that particular location, what is the location? I'm putting downloads in the location. I want to list the directories. And if the file is ending with a PDF, then I'm saying use the shell utility command. Within that, you're using move to move the file from and to. That's the whole point if I talk about, right? So, it's always good to. So, small pro tip here. It says like automate your file management system. Managing your files, right? So, to keep the workspace tidy, because many a times we feel it cluttered, right? So, and many times, like the fun way of learning Python is basically doing small projects on the same as well, right? So, to manipulate the stuff and stuff. So, guys, let's quickly move to the next important aspect, which I wanted to quickly talk about, right? Especially when it comes to the libraries which you use in data science and AI, if I talk about, right? So we have for the numerical analysis, you have the NumPy, scientific Python, if I talk about in the context, right? Then for data manipulation and any kind of modification you wanted to go ahead and do, you use pandas for that, right? If I talk about, you can see data cleaning and analysis and stuff, right? Matplotlib, Seaborn, high, like basically, I think we all safely understand that Pandas is built on top of NumPy because NumPy arrays are way faster compared to regular lists, right? If I talk about, right? And that's what makes it much more interesting to look into. Then there's the Matplotlib built on top of, what do you say, the basic Python plotting library. You have Seaborn and Plotly advanced visualization tools. If I talk about, and Plotly is, off the charts. Like you can interact with your plots on a real time basis, right? If I talk about, but aesthetically, Seaborn is really good, especially comparing it to Matplotlib. But Matplotlib is the base library for Seaborn and Plotly as. So if I talk about. Same way, moving forward for machine learning, like because we are talking about data science in the context here, you have scikit-learn, you have PyTorch, TensorFlow for DL-based works, right? If I talk about, again, TensorFlow is a very big library now that we can picturize how the library structure actually works out, right? So talking about, and you can always minimize the footprint of the memory footprint by pinpointing what do you want to extract. So that's the whole point, right? Best practice to work around with. And then you have natural language processing. For that, you have NLTK and highly advanced. If I talk about, it's not just into NLP, but a lot of wide variety of things. For generalized tasks and everything, right? Wherein you can have different encoder based architectures, or maybe decoder based architectures, or maybe encoder decoder based architectures and stuff. So transformers, if I talk about in the context there, very highly high advanced. If you talk about in the context, just like how we talk about the chat GPT, right? Or generative pre-trained transformer.